Hi, I'm recording. I think I'm recording. Let's see if I'm recording. Yep, I'm recording. So I'm recording a little video for you guys for this worksheet assignment that I gave you for the iGEM registry. So what I have on here, and I'm going to try to annotate, is a list of plasmids and a list of parts. Okay, and what I wanted you to try to do is I wanted you to look up the plasmids in the iGEM registry and determine what kind of antibiotic resistance gene they have, and then what size the plasmid is. And then I wanted you to try to do a little bit of math and convert the size in kilobases to base pairs, because a lot of the information that's given to you is going to be in base pairs. Okay, so I think everybody did okay with this top part, but then you were having problems with the bottom part. Okay, so these are the things that I had you grow from the glycerol stalks the first day. So there's different parts here. So let's see, let's try to copy one of these. Okay, so whoops, wait a minute. Let's see. Clear all drawings. Okay, let me go in here and try to select or highlight, see if I can do it. I might just write it down. So BBA is the common number that they give everything. And then let's just look up the one E0040. Okay, the second one I have on here. So basically what we're gonna do, let me try to get to the other screen I have here, the tab I have. Close that, okay, and go here. Okay, so this is the step before I think I gave you. So here's the registry. So basically what people do is they develop parts and they put them in plasmids, and then they register them with this iGEM, which is the International Genetically Engineered Machine. Okay, so the parts, in order to put them in the registry, you have to have them sequenced, and the sequences have to be demonstrated that they're right. So everything is kind of quality control. It's supposed to be double checked before it's put in here and before you can get the part and actually use it. Okay, so here's the registry of parts. Okay, they're putting them together with this BioBricks method, right? And we have a bunch of parts. So I have access to a bunch of parts. Okay, so if we go to the registry, okay, here's the registry of the parts. So if you go up here, this BBA thing, that's where we're gonna search. And you can go through here and you can just kind of start looking. So some of the parts that we are gonna use are in this Uppsala chromoprotein collection. Okay, so we're gonna use through these. So registry help. Okay, so the prefixes and the suffixes, the assembly standards. So if we look, BioBrick prefixes and suffixes. Okay, so what these are maps of plasmids. Okay, so here's the plasmid that it's in. So here it's SBP, so is plasmid SB1C3. Okay, so here is the plasmid it's in. Okay, and this is the part we're looking at. Okay, so the sequence of, let's see, it's going to have it on either side. So the prefix is over here and the suffix is over here. If you look, okay, the prefix is going to always have eco R1 in it and this XBA1. Okay, the suffix is going to always have the SPE1 and the PST1, which we kind of tried to talk about that. Okay, so these are the restriction enzyme sites. So this is going to be where they're going to cut, and we need to talk about restriction enzymes. Okay, so this is the plasmid. So now from that top chart that I gave you, what would be the antibiotic resistance gene? So if it has a C, that means it's chloramphenicol. Okay, so that's the thing that they're going to use. Okay, now that's the antibiotic. So if we go back here, let's see. We can put this one that we're going to look for in here. So we can put in E0040. So I'm entering that in. Okay, and here's the part. Okay, so basically the part name, okay, so if you go back to this assignment, okay, I want the part name. Okay, so here's the number, I'm giving you the number, BBA0040. So if you go here, the name is green fluorescent protein derived from jellyfish Aquia Victoria wild type GFP. Okay, so that's the part. So they gave us some information about the part. Okay, so let's go in here. You guys could add the part name. Okay, and then so they've adapted the part to assemble transcriptional units with the Golden Gate method, and we've done the characterization of this protein. Okay, so here's the group. They did it in 2018. Okay, here's the people, Gutierrez and Ropero. Okay, now the characterizations of the protein and by extension all of the other part that could codify for the GF was performed with our transcriptional unit this transcriptional unit was assembled in a golden braid alpha 1 plasmid including the following parts. Okay, and I don't even know what a golden braid is. I'll have to look up golden braid. Okay, so here's the promoter. Okay, here's the ribosome binding site. Here's the part. Okay, and then here's the terminator. Okay, so basically this is what's in this plasmid. Okay, so it's got a promoter, it has a ribosome binding site, it has the GFP, and then it's got a terminator. Okay, so in order to carry out a correct characterization of the protein and be able to use it to make measurements of different transcriptional units that we assembled with it, we've obtained an emission and excitation spectra in the conditions. So then they gave you the protocol that they used. So we can talk about fluorescence, but fluorescence you have to excite. So you have to emit and excite. So we can go back and talk about this. So they excited it at this wavelength, and then it fluoresced or emitted at this wavelength. So think about the GFP E. coli that I gave you. So remember you had to shine a light on it. You had to shine the UV light on it. So that's the emission, okay, or the excitation rather, sorry, that's what's going to excite it. And then it's going to emit light at a different wavelength. Okay, so we see it. All right, so then we're not worried about that. Okay, we're not worried about that. Okay, so then this is just all the information that other people have done with it. Okay, like how long it took for it to glow. Here's some pictures of it. Here's some more stuff about it. Okay, there's even more stuff. So there's just a ton of information about this part. Okay, so there they are, you can see it. Okay, now we want to find information about the part, right? So if we go here, information. Okay, so here's the description. Okay, here's more about it. And then down here, we're gonna view plasmid. Okay, here's the size of the part. Okay, so it's 720 base pairs. Okay, and let's view the plasmid. Let's see what we get. Well, come on. So it's not letting us do it. Does not show sample ability. So we know it's in that backbone. Let's just go here. Oh, usually we can see it. Okay, hold on. Okay, so the other questions, let's go back here and let me look at the other questions I asked you. Okay, so we want to try to find the backbone, right? We found the size. Okay, we want the plate and where it's found. So let me go back. All right, so DNA status, it's available. Okay, it works. Okay, color, it's green. Here's the direction. There's the protein. There's the tag. Categories. So here's how they're organizing it. Wait a minute. Get plasmid, get part. Where did it go? Sequence and features. Okay, so it says it's in stock. So where is it? Part status. It's in the repository, so they have it. And it usually tells you exactly where it is. Hold on. Page header, page footer, sequence and features. There's a sequence. Okay, there's if it's double-stranded. It's cars. Wow, hold on. Access. Now I can't find where it is. Usually it tells you right where it is. One registry star. Get this part. Click on get this part. Okay, so if you say get this part, okay, it's going to take you. All right, so this is the secret. This is the part that we've been messing up. Okay, so if you go back, right, and you have all of this, okay, and you want to get the part. Okay, so you say get this part. All right, so let me try to circle it. Draw. It's not gonna. Draw. Get this part. Okay, so then what you can do is you go here. Okay, get the part from the part registry. I'm just going to click on more. So basically, what happens? Let's go back. Okay, is it's going to tell you where it is. Okay, so it's going to say, okay, in 2019, it's in the kit. It's in plate 6. Okay, so plate 6, and then this is the well it's in. It's in well 13K. So in the 2019 distribution, this is where it was. Okay, here's the backbone, SB1A2. So that's the plasmid it's in. So it's in the one with ampicillin in it. Okay, so they sequenced it, and here's the information. Okay, so it's got green fluorescent protein. Okay, here's the sequence data. Here's the plasmid backbone down here. Here's the specified resistant, so it's ampicillin resistant. Okay, and this is just the sequencing information. Okay, so I think that will help you. So you guys go back. What you're gonna look for when you enter in a part number is you can find out information like the name and everything from this basic stuff. Okay, and I think it's interesting just to look at it because that's how you're gonna learn about it. But then if you say, get this part, it takes you to the details about the part. Okay, and that's what's in this database. Okay, so here's the plate location. I'll bring the plates and then you guys can see them. There's the backbone, and then you can figure out what antibiotic they're resistant to. All right, I hope that helps.